The moon's gravitational pull causes the oceans to bulge, creating 2 high tides and 2 low tides every 24 hours, with the average tidal range being approximately 0.8 meters. However, during the new moon and full moon phases, the gravitational pull of the moon and sun work together to create even higher high tides and lower low tides, known as spring tides, which have an average range of 1.2 meters. This phenomenon is crucial for navigation, coastal engineering, and marine ecosystems, as it affects the distribution of marine species and the erosion of coastlines. For instance, the increased tidal range during spring tides can lead to coastal flooding, with an estimated 143 million people living in areas less than 10 meters above sea level, and the World Bank predicting that the global cost of coastal flooding will reach $1 trillion by 2050. Here's why that matters. Tides are the periodic rising and falling of the sea level caused by the gravitational interaction between the Earth, Moon, and Sun. The Moon's gravity has the most significant effect on the oceans, with its gravitational force being approximately 2.2 times stronger than the Sun's. The Earth's oceans are made up of approximately 1.3 billion cubic kilometers of water, and the tidal force causes this water to bulge out in 2 areas, one on the side of the Earth facing the Moon and the other on the opposite side. This results in 2 high tides and 2 low tides every 24 hours, with the average tidal range varying from 0.5 meters in the open ocean to over 15 meters in certain coastal areas, such as the Bay of Fundy in Canada. The mechanism of tidal forces is based on the gravitational interaction between the Earth, Moon, and Sun. The Moon's gravity causes the water molecules in the oceans to be attracted to it, resulting in a bulge in the ocean on the side of the Earth facing the Moon. Similarly, the Sun's gravity also causes a bulge in the ocean, although it is much weaker than the Moon's. When the Sun and Moon are aligned, their gravitational forces work together to create an even greater bulge in the ocean, resulting in spring tides. The strength of the tidal force depends on the distance between the Earth and the Moon, with the force being stronger when the Moon is at its closest point, known as perigee, and weaker when it is at its farthest point, known as apogee. The tidal force also depends on the angle between the Earth, Moon, and Sun, with the force being stronger when the 3 bodies are aligned and weaker when they are at right angles to each other. The tidal patterns are more complex than just the simple bulging of the oceans. The rotation of the Earth, the shape of the coastline, and the depth of the ocean all affect the tidal patterns. The Coriolis force, caused by the Earth's rotation, also plays a significant role in shaping the tidal patterns, with the force being stronger near the poles and weaker near the equator. Additionally, the tidal patterns are affected by the resonance of the ocean basins, with some basins having a natural resonance that amplifies the tidal forces. For example, the Bay of Fundy has a natural resonance that amplifies the tidal forces, resulting in the highest tidal range in the world, with an average range of 16.3 meters. The complexity of tidal patterns is also influenced by the wind, atmospheric pressure, and the movement of the Earth's crust, with these factors affecting the tidal range and the timing of the tides. The study of tides has significant implications for our understanding of the Earth's oceans and the impact of human activities on the coastal environment. The rising sea levels and increased storm intensity due to climate change are expected to exacerbate coastal erosion and flooding, with an estimated 143 million people living in areas less than 10 meters above sea level. The World Bank predicts that the global cost of coastal flooding will reach $1 trillion by 2050, making it essential to understand and predict tidal patterns accurately. The study of tides also has significant implications for navigation, with the accurate prediction of tidal patterns being crucial for safe and efficient navigation. The International Maritime Organization has implemented regulations to reduce the risk of coastal flooding and erosion, including the requirement for ships to carry electronic chart display and information systems that provide accurate and up-to-date tidal information. Tidal energy is a promising source of renewable energy, with the potential to generate electricity from the predictable and reliable tidal patterns. The first commercial tidal power station was opened in 1966 in La Rance, France, and since then, several other tidal power stations have been built around the world. The Maygen Tidal Array project in Scotland is one of the largest tidal energy projects in the world, with a planned capacity of 398 megawatts. The project uses underwater turbines to generate electricity from the tidal currents, with the turbines being designed to withstand the harsh marine environment and to minimize the impact on marine life. The tidal energy industry is expected to grow significantly in the coming years, with the International Energy Agency predicting that tidal energy could generate up to 750 gigawatts of electricity by 2050. In conclusion, the Moon's gravitational pull has a significant impact on the Earth's oceans, causing the tides to bulge and resulting in the periodic rising and falling of the sea level. The study of tides is crucial for our understanding of the Earth's oceans and the impact of human activities on the coastal environment. With the increasing threat of climate change and coastal flooding, it is essential to continue monitoring and predicting tidal patterns accurately. Subscribe for more deep dives.